Go.
Hello, and welcome to Respain Tula Industries workshop video about limiting and excess reactants. Okay, first of all, let's define some key terms. What exactly is a limiting reactant? Right, a limiting reactant is a substance in a chemical equation that is used completely. This means that the amount made in the substance is dictated by this particular reactant. Okay. Excess reactant. The opposite, okay? It's the reactant in a chemical equation that has the greatest amount. So it has an amount that is more than the limiting reactant, okay? Okay? So let's get through some steps, right? The first step is that you need to read the problem, okay? And make sure the equation is balanced. Okay? Then you have to convert your given amounts, okay, whether they be in moles or in grams. You have to convert them into moles, okay? The little side note is that if the given amounts are already in moles, you can skip this step, okay? After you convert your given amounts into moles, okay, you have to divide the moles by the coefficient, aka the big number. Okay. Okay. After completing steps 1 and 3, you just act like it's any other equation. Okay, so let me go through some
So to
examples.
find the limiting reactant or an amount produced of any substance, we have to follow this equation and have to break this down. So we're going to start by finding the limiting reactant. And by that, we have to find in the question what's given. So in this case, 200 grams of FeTO3 and 300 grams of carbon are the substances that are given. So first, we have to find the limiting reactant. So we would write 200 grams of Fe2O3. And then on the other side, 300 grams of carbon. So since this is not in grams, and we have to have it into moles, we're going to do a small stoichiometry problem when converting it into moles. So like that, we'll be able to divide it by the big number. Okay, so to find this, you go to your periodic table and look at the small number on your top right, I think. So you get 159.69 grams of FeTO3. So since we already canceled grams, we put 1 mole at the top. And we are at moles now. So you divide these and you get 1.25. So now we're going to convert the grams of carbon to moles. So in order to get to moles, we have to cancel out grams first. So we'll go to the periodic table and we will get 12.01 grams of carbon. So now that we cancel out grams, we have to get to moles, so we put 1 mole at the top. And then we get 24.97. Okay, so now to find the limiting reactant, we divide by the number here. So we'll look at its own coefficient. So we go to Fe2O3 and its coefficient is 2, so we divide by 2. And for carbon, its coefficient is 3, so we divide by 3. After dividing that, we get for grams of FeTO3 0.625. And then for grams of carbon, we get 8.32. Okay. So Now, obviously, limiting reactant is the amount that is the smallest. So in this case, our limiting reactant would be grams of Fe2O3, and our excess reactant would be grams of carbon. Okay, so now that we have our limiting reactant, we go back to our question and read the question. And it says, how many grams of Fe can be produced from a mixture of 20 grams of Fe2O3 and 300 grams of carbon? So we want to get to grams of Fe. So now that we have our limiting reactant, we use our limiting reactant to get to grams of Fe. So we're going to start with grams of Fe in our equation. So we're going to put 200 grams of Fe2O3, and then from there convert to mass. So at the bottom, we look at our periodic table and we get 159.69 grams of Fe2O3, and we always put 1 more at the top. So now for this is where we look at our equation to cancel out moles. So we look up here and it's 2 moles of Fe2O3. So then, since we're already at moles, now we want to convert to Fe. So we look at up here and this has 4 moles of Fe, so we'll write up here 4 moles of Fe. So now we want to get to grams, now that we have reached moles. So to cancel out moles, we put 1 mole at the bottom, and moles are canceled out. Now we find the grams of Fe, and once that is done, we multiply the top and divide the bottom. So then we look at our periodic table and we get 55.85 grams of Fe. And once you multiply this number, that number, and this number, you get a sum, and then you divide it by these 2 bottom numbers, which gives you in total 139.9 grams of Fe. So now we know that in order to get the amount of produced, first we have to find our limiting reactant, and once finding our limiting reactant, that is the given we start with. So here our limiting reactant was Fe2O3, so we started with grams of Fe2O3 and converted to grams of Fe. So now we know that 139.9 grams of Fe can be produced with a mixture of 200 grams of Fe2O3. So now, since we know how to do the limiting reactant, we go on to the next problem. So this problem says how many grams of P2O5 will be produced with 17.0 grams of pH and 16 grams of O2. So since we already know how to do our limiting reactant, I'm just going to give the limiting reactant. And the limiting reactant is O2. So now we know that we start with 16 grams of O2. So 16 grams of O2 is what we start with. And we want to get to grams of P2O5. Okay, So we get our mass from the periodic table, and that is 32 grams of O2. This is because in your periodic, so our limiting reactant here is O2, so this is why I started with 16 grams of O2, and we want to get to moles of P2O5, 2 grams of P2O5. So in order to cancel grams, we have to put grams at the bottom. So you get 32 grams of O2 from your periodic table. And like always, you put 1 mole at the top. And then you want to cancel out moles, so you'll put moles at the bottom. But this moles, you'll get it from the equation. So if you go to O2, it has 4 moles. And then now is where we could get to the moles of P2O5 because it's on the periodic table. So since P2O5 doesn't have any numbers here, it's an imaginary one. So we put 1 mole of P2O5. So then at the bottom, we want to cancel out moles to get to grams again. So we put 1 mole of P2O5. And now that we have reached grams and canceled out mole, we find the grams from the periodic table again, and we get 41.94. And like to find the total sum, you multiply the top and divide by the bottom, which gets you to 17.74 grams. So first we found the limiting reactant, then we went to our problem, broke it down, and since we know that our limiting reactant was grams of O2, that's what we started to convert to how much would be produced. So now we know that 17.74 grams of P2O5 are created when using 16 grams of O2.